Ready? Let's go. How's it going? Good. Yeah. Okay, so I'm Russell Butturini. I'm the Senior Enterprise Security Architect at Helpways, where I work with Willie. He's only in here because he laughs at all my jokes and all my PowerPoint slides. And so I'm going to be doing a presentation today on automated NoSQL exploitation of NoSQLmap, which is a tool I wrote. Talking about some security deficiencies in NoSQL, particularly MongoDB. Those are generally all about the same. Before we start, just for a quick survey, how many people work with a NoSQL database or using it? What do you think? Good, bad, like them, hate them? Okay, good. Good experience with it. Awesome. So you have to put the obligatory About Me slide in, and you see I've also changed this from Manchester United to Liverpool, just for Mr. Rojas, who was just in here. But I break Helpway stuff for money, pretty much. That's what most of my job is. I'm a web app tester and a subpar coder. I also got in a huge fight with the little girl Lauren, who was just in here during an audit a couple years ago, so that was a lot of fun. And yet these people still, despite my annoyances, had me to speak today. And I'm the father of the world's loudest and cutest 6-year-old, which your biography in the program says 5, because I can correlate that this was after her birthday. It happens working IT. So this presentation has a lot of jokes from Blazing Saddles. So, if you haven't seen the movie, none of them will make any sense, none of them will be funny. If you have seen the movie, I hope you think they are funny. So, just you can take that for what it's worth. We'll start right off more, actually. Let's talk about Mongo, but not this Mongo. Mongo is just a pawn in the game of life. So, Mongo was a big, burly character from the movie. He wasn't the brightest guy in the room, but he was one of the bad guys in the movie who turned good later. But what about this Mongo instead? MongoDB, which is a NoSQL platform, is just written by TenGen. There's a open source version of it. There's an enterprise version of it as well. It's I think about $7,500 a year for server license, the enterprise version. Some differences in feature sets and stuff. I've only seen, mostly seen rather the open source version. So that's probably what you'll find as you go out pen testing and exploring enterprises. But I started thinking about it, and they're kind of the same. They're both big. MongoDB's not a whole lot of data. Mongo's a big guy. They're powerful. MongoDB solves problems and complicated queries. Mongo's a guy not so much, but he can at least push things. They kind of blindly trust everything. So in MongoDB and NoSQL databases in general, anything you feed them, anything you tell them to do, they'll just do it. So you don't have this concept of schema that you had in a traditional SQL database. If you insert something that doesn't exist, they'll just insert it. So they do anything they're told, and neither one of them seems to understand encryption. And we'll talk more about that later. So why did I pick on MongoDB? We were talking a little before I started. It's the first thing I had to learn, just because of me at something we were doing Helpways at the time. But it's pretty heavily, has a pretty heavy market penetration rather, in the NoSQL market. And they use this statistic, and this is a new statistic I've never seen. And I had to put footnotes to prove I wasn't lying. They actually use this in the press release. 49% of LinkedIn member profiles mentioning NoSQL technologies reference MongoDB. Now that could be we ripped MongoDB out. I don't know. But that's actually what they use to sort of demonstrate their market penetration for NoSQL. They put out a lot of releases with big changes. So pretty much your major releases are a 6-month cycle with Mongo. And it actually says in the manual that the changes they introduce in their major revisions will introduce new features that break backwards compatibility. Now, their history has been they don't really care. So if you're on Mongo 2.2, this is a good example, and you upgrade to 2.4, they actually took out a whole bunch of classes you could access for queries. And their answer to that was, if you have to use the stuff we took out, rewrite the code. That was it. There was no backwards compatibility, nothing. And they're pretty oblivious, and I got this from the Security Weekly podcast, which Jack, who just heard upstairs, is on. They had a guest, Rich Vogel, last fall. And he said they were talking to MongoDB guys, and it's clear that they just didn't care about security because their customers weren't asking for it. And I think a lot of the reason for that is NoSQL platforms, MongoDB, are really, really targeted at developers. So developers are sort of get the code out the door first. What's easiest? Let's do the security last. So if you're not doing NoSQL, quick tutorial. In traditional database, you have databases, you have tables, column types, rows, records. Typically, it's very static, right? We have columns, and each column has a particular data type. Rows and records must fit a certain format. You don't insert things that don't exist. In Mongo, the data structure is much more logical. So you still start with container databases, and then inside databases you have what we call collections. And collections are these groupings of documents, which is a collection of key value attribute pairs, basically. And there's really no similarity required between the elements inside one database or inside one collection. One can have 3 key value pairs, one can have 5. One can have a key value pair that uses a string, another can have the same key value pair that uses an integer as a data type. So you see this, you have this much more logical, dynamic schema. And probably, you work with databases or develop, know where that might be advantageous. It's a lot easier to refactor code and change the way you're storing things. So look at how data is stored. A real simple example. As we talked about before, you have columns, you have very static set of types. So in our example, you have a field that has char type, you have a field that's bar chart type, and widgets, integers. And in Mongo, you see there's sort of the Mongo representation, the first example of what it would look like. And then you see in the next example, we've actually changed the data type from an integer to a string, where we have 2 records, something different there. Or we can insert an extra attribute that doesn't exist in the other records. Because insecurity, adding things that blindly trust everything always works. Okay, queries, it's really more syntactical. So if you look at the Mongo sort of syntax between the traditional SQL syntax, it's just a give me username Joe back. And set 1 from the email, or give me a key value pair to do Joe from the email, key value pair for that record that matches that. The way Mongo stores data, I should have mentioned before, is in a format called Bsides. So that's binary JSON. And what that is it's actually JSON on steroids, and it has some encoding, decoding performance enhancements in it, and it will also allow you to store more data types inside of JSON. So it's good, right? I mean, they're built for performance. They're easy to scale. They do what they need to do, and they can suck up gobs of data. You can distribute problem solving across multiple servers. They're very dynamic, flexible. Installing Mongo, installing another Mongo server to your environment, pretty much a 10-minute job. That maybe one config change to make it replicate from other servers. But then we start getting into some security stuff. This is security package, right? We got to talk about security. So there's really not any standards between the NoSQL platforms. What works one way on Mongo works a different way on Couch, works a different way on Redis, works a different way on Cassandra. So you kind of have to pick the right platform for the job. There's different feature sets, and depending on what kind of data you're trying to store, what security requirements are around that data, you may need to pick a different platform. Security is weak, it's very inconsistent, and I'll go through with you the way Mongo sort of visualizes security for the platform, and that's, they pretty much say, we're your data aggregator. We're going to suck all your data in, we're going to store it, we're going to make it easy to find, we're going to index it, but if you want to do security, you do it at the application layer. You don't do it at the database. Now the disturbing, and that was the most disturbing picture I could find in the latest session. It had been marred about talking to Sprawl. Most of the NoSQL platforms have no authentication required by default. And that's definitely through MongoDB that you can install it and it's full access there. The password storage in some platforms is plain text, and in other platforms it's weak. In Mongo, it's MD5. I wish Josh was here. It's like they take the username and put a colon and the word Mongo, a colon, and then the password, and then they just hash it in MD5. And that's the password. Everything is in clear text, and you see the next 2 points. Actually, that footnote, there was a change between 2.4 and 2.6, which was released middle of last month. And so we'll talk a little bit more about these things later. There's no inherent data encryption, so no field level, no database level encryption in MongoDB. There's no encryption over the wire as far as data going back and forth between your clients and your servers. This is actually a quote from the manual. It says, use this only in trusted environments. And apparently some people think the internet is a trusted environment. And like we talked about before, there's a heavy reliance on clients and drivers pushing all the security model away from the database and onto the applications themselves. So NoSQL was no auth, at least by default. So I pulled some data from Shodan. This was about 6-7 months ago, and I found there were about 33,575 Mongo management ports, 27017 TCP, exposed to the internet. And I thought, well, I wonder how many of those have the default authentication scheme, none, turned on. But that's kind of an ethical gray area to go connect other people's stuff and look at it. So I called this guy. Who knows who this guy is? Can anybody tell me? Nobody. This is Paul Asadori, who runs the security weekly podcast. This is the best picture I might find. He made some interesting comments during my Bsides Rhode Island presentation last year, so this is payback for that. But when he does ethical things, or unethical things, or ethically gray things, he calls the guy named Bob to inform. He never does it himself. And Bob does it. So I called Paul and said, I need to borrow Bob. I need Bob to go and maybe write some Python code which tests all these 34,000 servers and sees how many of them are anonymously accessible. And Bob said, yeah, sure, you can borrow Bob. And I get Bob, he writes the Python code, and this is what Bob found out. Out of those 33,575 servers, 18,979 of them had no authentication turned on. So 56.5%. And Bob saw lots of interesting things like e-commerce website data, forums, names, and email addresses, and other personal information. Lots of those things. And as far as the rest, the data on Shodan it gets kind of dated or stale. Most of it was offline. There was under 1,000 that actually had authentication today. So take that for what it's worth. And again, this is the quote from the manual. Can we use RTFM? I should ask what words I want to use today, so I'm starting my lighting in the parking lot. Fabulous. Read the fabulous manual. I like that. Yeah. So the most effective way to reduce risk for MongoDB deployments is to run your entire MongoDB deployment, including all MongoDB components, MongoD, MongoS, and application instances in a trusted environment. So the conclusion I draw from this is that 18,979 people have never heard of Snoop, and the internet is a trusted environment. Yeah. But there's more. The authentication config is all held outside the database. So if you get shell on the server, there's actually a line in the MongoDB.com that you comment it out, it turns authentication off. When I say turns authentication off, it doesn't mean anything new doesn't get authenticated. It means it turns it off. So everything that was already in the database, if it's authenticated locally, if you have shell, you turn it off, you get the service, Mongo, client, your database. Run will act as a shell. And this can be confusing if you're connecting remotely to a server. And it confused me. Not that I confused Tracy. But you can basically run commands and you start and we're in the context of MongoDB, MongoDB account. And what I thought was happening was I was getting shell on servers. And what I discovered was my NetHead listener was getting shells on my own machine. Oops. But yeah, if you have local access to a server, you can actually, from the Mongo client, access Mongo. So drop all that off there. That's fine. The clients are designed to move database around really easily, which is good, for scalability and things like that. But it becomes bad if somebody has access to your database. They should keep running the entire database out with one command. Should that then. There is a default web management interface running on 28017, but that is actually turned off by default. 2.6. Like we talked about, there's a lot of incentives not to upgrade, so you're going to find a lot of 2.0, 2.2, 2.4 still floating around out on the internet. There are quite a few of these exposed to the internet as well on Shodan. And there is a REST API that you can query the databases through the web interface as well. It's not turned on by default, but So NoSQL equals no encryption. Server-client communications, including authentication, occur in plain text. But it uses a nonce over the wire, but it's weak. And so if you can sniff an authentication, you can crack it. And there's some code that's going to go into nosqlmap 0.4 for cracking credentials into the wire. So password encrypted MD5, we'll talk about they're weak, but at rest they're not really encrypted. And you're on your own for data encryption, except for one very specific case that we were talking about. And NoSQL equals no SQL injection. That was the first thing I read when I started researching. Oh, there's no more SQL injection. And yes, can you walk up to a NoSQL web-based web application and go, equal 1 equals 1 dash dash? No, that doesn't work anymore. But changing the syntax does not mean you eliminate the vulnerability. So everything you're able to do before, you need to convert to JavaScript. So JavaScript is the query language in MongoDB. Between versions 2.2 and 2.4, they actually switched from the SpiderMonkey interpreter to the VA interpreter. I think those classes out like this. But it's the same concept. So if you look, you close off a variable, you insert your own stuff, and you'll notice I've got this thing in yellow. It doesn't care what you go query. This statement will return every record in the database, and it will use the configuration however the client is configured. So it doesn't really matter. You don't have to build naming. And then you just create a dummy variable. That way your syntax is correct. And this is a query called a where query. And so what this does, and MongoDB never uses this. They say, where query is very dangerous. It basically lets you send JavaScript to the server to execute. Now, that sounds worse than it really is. You can't do things like start sub-processes. Some of the traditional JavaScript things you can do is compare, but if your goal is to steal data, this still works. But the other problem with them saying never use the where query is if you need to massage data or manipulate data before it goes to the server, they say don't use stored procedures on the server side either. Well, so don't use the where query in code. Do the JavaScript, manipulate data. Don't use stored procedures on the server side. What do you do? It's walking contradiction. So in Mongo 2.4, they took out the ability to access the DB class. And I think that was a security thing, because you could get things like DB system users, DB database name, things like that. But they didn't take out this little nugget, which is that any statement which evaluates the true, if you say return true, will return every record in the database. And so I use an example. You can just return true. You can return 1 equals 1. Or you can return this other thing. Now, let me explain this. Mongo, from its perspective, thinks that everything exists. So if you give it a random string for a collection name, it's like, yeah, that exists, and it's equal to null. So this statement says, give me this thing, which is equal to null. You can return this, which is equal to null. And if it's not equal to this other random thing, because it's equal to null, that equals true. Does that make sense? It's kind of confusing. But so essentially, you can mutate these infinite number of ways. Then you have the client issues. Like we talked about before, they enforce a lot of security at the client level. So PHP has some interesting problems with its MongoDB driver. And PHP, if you know it, will take anything in square brackets and turn it into an associative array. So if you say, give it this, at the top, take parameter name and bracket $any, which is actually MongoDB's export not equals, and something. PHP turns that into an associative array, which not equals something. And that's what the MongoDB driver in PHP wants. And basically MongoDB can say, it says, give me everything back that's not equal to whatever. So, yeah, that's where client-side security and enforcing it away from the database is really fail. But I'll give credit where credit's due. On March 8th, or April 8th, I'm sorry, they put out version 2.6. Wow, I was in the doctor's office, so I read it on Twitter. You never have to get a security exception from your security team to run MongoDB again. Fantastic. My whole talk is shot. I'm going to read it. And, they put in some new authentication schemes. They added certificates and Kerberos and some other external sources. They turned the web interface off. All right, that's good. They added some role-based access control and some things. They changed some auditing and logging. The logging is not very robust, whereas it's pretty good before. Encryption transit over SSL. Cool, they added that. That's great. And you can do encryption at rest in base field level. Awesome. So I was like, all right, I'm going to go home and look into this, see if I got to rewrite my whole talk. But not so fast, my friend. I hate it. There's still no authentication turned on by default, even though they put all those new authentication methods in, right? The default distribution on MongoDB does not contain SSL. So if you want SSL, you have to recompile it all locally, including every time you patch it, okay? Or by the enterprise version 7.500. Because on encryption, I thought we just said, oh, they provide you somebody doing an open source plugin or whatever. No, you go to the website, it's many tens of thousands of dollars. And password hashing, still the same for local users. So I took all this, I've done all this research, I've done all this exploring, and I said I need to write something to make this easy for pen testers and to demonstrate, and nosqlmap came out the other end. And so the project homepage, I'll have this at the end of the presentation, is here, but it's basically automation for all these things we just talked about. And, you know, I gotta just take a minute and thank all these guys. Horazio was a guy who just randomly found source code on GitHub, and I just put it under backup. He emailed me, oh, this is great, you know, we can work together on this. Actually, he personally said, I want to write a blog entry. I said, well, you research this stuff? Yeah, well, and here, come write some code. And we had a few disagreements about how code should look at things, but as far as ideas, we kicked some things around, features. And he's moved on to bigger and better things now. He lives in London, and he's an artist, so we forgive him for that. So, yeah, anyway. Mid-chow, you gave a talk at DEFCON 21 called Using NoSQL Databases, where sort of some of my interest started in this stuff. And he's a phenomenally smart guy. He teaches at Tufts University in the computer science department. He's a good QA and guy to bounce ideas off of. Josh, he works on security team Healthways, is not in here, but he wrote some of the password cracking and some hash stuff that you can see. Jason Haddix, this guy works for HP Shadow Labs, and I didn't know what was going on with that. With us for work. Jason had found the tool and like posted it up, and Jason's like a gazillion followers. I mean, it's literally like it says a gazillion when you look at his profile. And he had like, it's so great. People started retweeting it out. People started contacting me. Oh, this is great. This is unbelievable. You know, it would work better to do this. You can do this. You can add this. And that's really the last point. I've got a lot of feedback based off Jason's appreciation, compliment, and feeling for sharing. So that's the sentiment portion of the presentation. So you guys want to see it? All right. I have my VM. This is my tagger VM called the Waco Kid, which if you really watch Latent Saddles, you know it's the guy, the Gene Wilder character, shaky shooting gun. So let's get started with the demo. So yes, I did steal the name from SQLmap. SQLmap is making it look good on many web application tests. But I did go with the menu-based interface as opposed to their command line switches because I am so annoyed with like typing a capital T when it's supposed to be a lowercase t or something like that, and screwing holding it up. It's like, I'm alright, menus. So the first thing we'll do, like we talked about, is look for. Does that show up for payment? Need a finger or anything? Good. Okay. Yeah. So let's look for anonymous MongoDB access using valves. So you can either load some a list of IPs or scan a subnet. Subnet. I'll shoot my little network here. Okay. But you see, we found some three anonymously accessible MongoDB. Okay. Which one do I use as a target? Since straight to nosqlmap, we'll just take the first one, for example, target set. All right. So before we go further, we need to set up a couple things. So as you see, the target host, we've already populated that. We're going to start with network attacks. We'll do the web app attacks after that. So we need these things for now. Default port, we know is 270.1.7. We need to set a local IP, which I forgot. Close your eyes. You didn't see this. Okay. Okay. And a shell list report, there's some code built in here, it's not really special, but it will automatically launch a Mongo 2.2 exploit, but we're going to do that towards this demo because it's a very, very specific situation in which it works. That for now. But I'll show you, also in my setup here, just so you know, I have my own MongoDB instance right on this laptop. And you'll see why we need that in a minute. But just general browsing the other options. You can save options out the file. You can actually parse a BERT request with web app stuff later. Yeah. So let's pretend we found this database, or this server hanging out here running Mongo, non-accessible. So we'll start DB access attacks, database server credentials. No, we know that because it's anonymous. And we check, yeah, there's MongoDB, there's the web app, no authentication required for the web app port. You can test the RESTful interface, I'm going to turn it on, so I'll skip that. There's so much to show and there's so little time here. So we start actually dumping out databases on the server. We start doing these databases, and inside each database we break out the collections. Then we look at something that's interesting. You see there's actually a lot of, in each database, a lot of system collections, so we can just look down what this does. We do have one that's app user data that's got a table or collection of users. And then it will start dumping out the database using password hashes as it finds them. Now, this could be because we turned authentication off. This could be because we've accessed the database authenticated. But I'm going to skip the password hash corrector now because I'm sure something a lot cooler with that here a little bit later. So, for that. Okay, tested GridFS. So GridFS is actually a distributed file system that works inside the database where we'll actually replicate files to multiple Mongo servers. So we have to check for that. We look and we actually see we have one collection user files that has GridFS turned on. It's got nice little images in there for the demo. But now the really important part, stealing a database. And it says, you want to do that? Yes, no. Requires your own Mongo server? I'll say, yeah. That's why we have to give our IP. Okay, which database do we want? Let's take one that says app user data. That looks like a good one, right? You didn't see that part before. And does database require credentials? No. We'll assume it doesn't because we're in the database, right? Okay, so we move the data to our laptop, and I didn't turn on indexing on my target database, so that's why that error shows up. So it won't move the index collection. But yeah, so what did we just do? Just going to show. Let's do that. So let's go back here. Let's go to our local Mongo instance. Now, this is running from my attacker machine. This is not running from the server. Okay, show DBs. Now we have database in there that we shouldn't have pointers to get out. But that's app user data underscore stolen. So let's use, and this is case sensitive, by the way. It's highly annoying. Show collections. Hey, it's collect from users, db.users defined. Okay, there's all the data in that database running from our attacker machine. So, yay! Alright. But, what if we don't have something like that? What if we don't have a database server itself? What if we have something that's a little more like this? Enter your customer ID. I should take out where I tested all this stuff like rigorously before I can to make sure I didn't have to do a fail. So, type your customer ID, there's your name, here's your customer, your credit card number, customer ID, CVV2 code. Yay! So let's actually see what we can do with that nosqlmap. So let's set our options up. Target host would be 10.100.165.91. Web app ports 80, app path, no, when we use the app path, we want to actually specify everything we need for members. Payments, count PHP, count ID 101, so we specify good requests in there. We can flip between get and post, for demo purposes, get's better than what we're doing. And I'm going to leave verbose mode off because it makes the output look really gross video also. So let's start web app text now. So first thing we do, we test if site's up. Yeah, site's up. Enter random string size. Now why do we have to do this? Basically what I'm doing is I'm going to give it some random garbage with the premise that if I give it random garbage and I give it insertable or executable code, rather, and insert the query, those things should be treated the same. So we should get the same HTTP response size back. Or roughly the same. There's a fudge factor built in the chain. 6 characters, what form we want to take, so bypass any validation check, anything else we got. This demo, which parameter do we want to inject? We'll inject account ID. And a bunch of stuff happens. Now what's happening here is we're simply inserting different things into the parameter, basically buzzing it, and we're checking to see how big or small the HTTP response size we get, what's the delta in the size, and if we get something over a certain amount, right now, then we get the injection successful. If we get something different, or something about the same, the injection doesn't work. Okay. So timing-based tests are not relevant to this example, but in MongoDB, we don't really have a sleep function for like a blind type of injection. But what we can do is we can insert a piece of JavaScript that's a while loop that checks the date over and over and over and over and over again until the date's 30 seconds in the future, and analyze the different HTTP response times. So that for now. And it says, okay, here's your vulnerable URL. We got that. So let's take that up. Let's copy it here. Let's paste it in our browser and see what happens. So what you see what we've done, we've got account ID, we've inserted a not equals parameter, and we've inserted something random that will probably never exist in the database. So again, everything's not equal to that random parameter that we generated. Boom. What happened? Everything in the database came back. So that's good. So let's try another example. We already made fun of you missed. I'll go back to that slide. Okay. So another simple example. I'll go back in, different web application, type in your username, give your name, user email address back, username. So let's try this one. This one uses where query. The first example didn't. It actually used the PHP driver. Let's that. Here. Take some different. Start over. This is so important. Post. Path. Okay. Everything else is fine. Back to the menu. I'm just double checking before I say that. Watch this thing go up. Okay, web attacks again. Okay, sites up. Give another random string, whatever, 8 characters. Same concept. We're going to be fuzzing. We're going to insert random things. All right. Again. Let's inject the user search parameter this time. Okay, you see this time the PHP associated array injection is not equals that failed because we were using that standard PHP driver query, where query. So we tested different types of where queries. We got a successful injection back on one of them. And we also tested this not equals query. So that's that anything evaluates true query, returns all records in the database. So basically, we said this dot single A right now is not equal to that random string we generated. So the two things actually work. Start timing-based tests. I'm going to skip those again for now. Okay. And then we actually get this prompt this time super different. Since MongoDB under 2.4 detected start brute forcing database info. So what this is we found a query where we inserted a reference to the DB class. We inserted the reference to the DB class. We got a successful injection. So we know because we got a successful injection referencing the DB class that the database is under 2.4, which means you can access other things in the DB class. Systems not users. So let's start brute force the database info. All right. So what's happening? First thing we do is figure out how long the date is. Okay, and this is pretty simple JavaScript logic. If the database name is length.length, because we return strings, they just use JavaScript string operator, is equal to 1, return true, else return false. We insert that in. We look and see did we get the same size back as our baseline when we sort of do, or we got everything back. So we know once we get a condition that evaluates true, if it equals 2, return true. If it equals 3, return true. That's length. And then we simply start the same sort of thing. And nosqlmap very much works this way as well. If first letter of the substrate, or first substrate, first character is an A, return B, and you make 100 requests. So then Yeah, we figure out it's 11 characters long. We figure out the database name in the back end is app user data. And let's try to touch other things in the database now. We have that. So get database users and password hashes. Yeah, let's do that. That's important. We found 2 users in the backend database. And we're doing the same thing again. We're actually essentially brute forcing username 1 character at a time. And then we're brute forcing the password hash, which actually is faster. Those are always a static link for 32 characters, right? So if it's an A, return true. If it's a B, return true. That's what we're doing. And so this will take a minute because there's so many requests involved. And so we pulled out user admin with that password hash. So imagine it should be very slow. This is single. It works good in a VM environment, but not so much. Yeah, so there's the hashes and we crack those. Yeah, let's do that. This is dictionary attacks right now. I need to write a report, but that's which one we'll crack. We'll take the admin one and pass this. Obviously, cookbooks to make it work right. Found username, admin, password. So we cracked the admin account through the web app. Same stuff we do nosqlmap, right? But you ask Mongo, you ask the company's SQL injection doesn't exist. Another hash. No, let's not do that. And there's our vulnerable URL. And just for the sake of the example, I'm going to show you that this is being inserted. So we actually inserted a return db dot garbage collection name find and a dummy variable again. Hit enter. All the records in the database come back, same way as we did before. Are we going? No, that's I planned on having some time for questions or whatever. So this is good. There's actually, I can give you a third example. Now this, just austerity. Order data. So this is actually running on Mongo backend that is on 2.4. So we don't have those loaders we had touched in the DB class. But just to prove the injection still works, and this is again simple order example. Okay. Illimar, 5 pieces above that. All my funny jokes. Yeah, so let's actually change wording this one. Yep, file. Continue. Some options. Same target host. We can change the app path. Okay. Try away that text again. Yes, apps up. We'll do an email address just to be funny. Doesn't matter. So you basically generate email addresses from garbage characters to garbage.com. Check the over search parameter. And we run through again, and sometimes this is something I need to actually work on and improve in the next version. We actually get an error back. And the error is so small that it seems much larger than the baseline. There's a much larger delta than the baseline. So sometimes you get false positives where the injection didn't really work, as with any group. So I'll show you timing this test just because we have a little extra time. Yeah. So basically we're inserting that while loop, just checking the data over and over again. Now, what I would say if you ever use this in production, don't, because I've seen it actually hang the entire Mongo server. It just won't do anything until the while loop ends. I don't know why that is. I've looked at the source code. But basically all we're doing, we're injecting it. We got a baseline HTTP response time we started. We're seeing if we got some damage. So you do actually got a difference of 30 seconds there. We injected a 30-second while loop. Okay. And we test it using a string escaping, so add the apostrophe and just integers. Yeah, so this is actually not MongoDB lesson 2.4. That's one of those false positives I was talking about. That's got to be fixed. But I know it's not going to work, so we're going to skip it. So, just inject this one. There we go. So you see we're injecting return. This .a is not equal to this random garbage we generated. And so even though it's 2.4, even though we can't access the database classes, even though there's not a driver problem, we can still pull all. So yeah, I mean, I got just I think one slide left here, and we can take some questions. Yeah. So final thoughts. It's a great tool. I mean, it's really, really easy. You can aggregate a lot of data. They can make problem solving distributed across a lot of different servers. They can solve complex problems quickly with sharding. You know, they're very cool, but you gotta understand what you're doing out of the box. I mean, look, I think what kind of data you're storing, and what are some ramifications that is breached or sit with the wire or whatever. You gotta do everything at the application layer, and that's I mentioned earlier. We use NoSQL-based applications, mongo-based applications to help ways. But what we've done, we've written custom encryption. So basically, everything's sort of written in the database, and the application will list inside. Unless you buy the new stuff in 2.6, it's a pretty heavy project. And don't rely on defaults. I mean, understand out of the box, there's going to be a lot of issues. There's going to be a lot of things that aren't turned on that should be turned on, or on like a traditional SQL server would be turned on by default. Just so don't rely on defaults. That's it. This is contact information. This is the project homepage. If you want to write anything down, there are on the web page. There's actually video demos of everything we did today. I'll probably put these slides up there at some point tomorrow. There's a lot of documentation, release notes. There's a link to the GitHub repository. I would love if anybody could really super Python coder to have people help. My code is really great test look. You can look at it. It's about 1700 lines. And that's actually shorter than it was. And it's all in English all that. But it's, you know, so making it a good tool. I need to work on support for the databases, couch, etc. So I can help that as well. Unfortunately, 3 times getting via premium right now. Project mailbox is there. If you want to send an email, questions, comments, or complaints, I'm the one that checks it. So actually, I'm ready to check it. So anyway, one of us will answer your question, but my English is better than this. Then that's how to get a hold of me. And yeah, I guess we've got some time left for questions. If you guys want to ask questions, make comments, you guys want to. Yeah.
Are there any IES products that can detect NoSQL injected data as well as the web firewalls?
Yeah, that's a good question. So the question was, are there any IDS, IPS, WAFs that will detect NoSQL attacks? And what I can tell you is that the OWASP Top 10 in 2013 added NoSQL injection to the A1 item injection. So explains some queries, things like that, and inserting arbitrary on the script. I have not seen one that has that, but I would not imagine that it's far off, given that the OWASP 2013 has updated that. Any other questions? Yes. All right. Well, thank you guys for listening. I really appreciate you coming today.
Thank you.
Yeah.